next speaker is Marjan Eggermont. I probably goofed that name, but sorry, Marjan.
Okay.
She's with the University of Calgary. She's a teaching professor and faculty member at the University of Calgary in the Mechanical and Manufacturing Department of the Schulich School of Engineering, University of Calgary. Marjan has a background in military history, fine arts, and computational media design. She co-founded and designs SQ, an online journal to provide a platform to showcase the nexus of science and design using case studies, news, and articles. And I really enjoy that uh, online journal myself. So appreciate you being here today, Marjan. I'll
Yeah, welcome.
give you the floor.
Sure. I'm going to share my screen if that's
Okay. Yes, sure.
acceptable. Um, there we go. Let's see. Okay. Everybody can see my
Yeah.
blue floating tardigrades over here.
Yes.
Okay. So just to explain the title of my talk, you may have recalled that there was a crash on the moon of a spacecraft in April, and it was a spacecraft that carried tardigrades. And there was a question, are these creatures going to be surviving on the moon? Not likely, maybe for the first couple minutes, but tardigrades are also known as moss piglets. So I kind of combined my love of the Muppet Show with the moss piglets. So we get pigs in space. So here you go. And I'll talk about that a little bit more later. So as Michael mentioned, I'm a teaching professor at a university in Canada, Calgary. It's snowing quite severely at the moment, so we already have a foot of snow on the ground. And I'm an editor designer of SciCode Quarterly, which is an online journal, open source, so all the issues are freely available. And I have a very varied background, which kind of echoes what Alex was saying in the previous talk, right? That biomimicry, bio-inspired design, right, really happens at that sort of space between disciplines and allows for a lot of collaboration. So I have a very brief talk, and I'm going to just show you some teaching examples and how I got to bio-inspired design and some of the projects that we've done with that with our students. So this is a question that I always ask, how did I get here? I had a sort of 7-year stint in fine arts, doing teaching and education and things like that. And then was asked by the engineering department to come and teach drawing to the engineering students. They decided that, CAD programs were great, but students needed to know a little bit of sketching before they went to 3D modeling and to CAD. So if you love drawing, keep doing that. So I started drawing with fairly sort of art kind of techniques in the engineering school, and the students did really great work. Just some examples here. And, we did all sorts of interesting drawings, on kind of orthographics and isometrics. If you're familiar with technical sketching, you'll be familiar with that. And I would ask students to find things that they could fold up at home and then expand, and then give me the isometric of the expanded item and then an orthographic of the collapsed item. And then looking at language and looking at form and function, right? There's a nice example of a Chinese character for middle, which really shows the word middle, as opposed to English. You could argue, yeah, there's 6 letters, so there is kind of a middle, but the character right at the top shows it a little bit more clearly. So I started to include bio-inspired design as concept generation, right, to come up with more sustainable solutions to design, and started doing that in about 2004. So we're talking eons ago. You probably weren't even born yet, so I have to kind of check myself here. But students started giving me these fantastic drawings. So here we are a couple of years into that introduction into bio-inspired design. So I would ask students, right, on the right-hand side, what are the challenges that these organisms are facing and how do they solve those challenges, right? And you could call that a strategy. And if you go to Ask Nature, right, you will see that term strategy crop up quite a bit. So they would do this nice flowchart, and at the end, at the bottom, you can see some design ideas coming out of that work. And then I also asked them, can you draw for me what you think is happening in the organism, right? So we get, of course, I'm showing you the best stuff, but we got some really beautiful things back. A couple more drawings, right? Some students are very creative. So I love the earthworm, all sorts of animations in the knife and in all sorts of things, right? Students showing that there was regeneration possible and that they had 5 pairs of hearts and all sorts of interesting things happening, right? So a very creative way to show what the organism or the stage of the organism was doing. So same with this cute little chick inside the egg, right? You know, how is it getting its nutrients? And the student did a really nice job of showing that and trying to kind of visualize, right, what is really happening here. So that was all kind of combined in a document. So if you are aware of issue.com, right, issue with W, if you do a search for biomimicry drawings, there's a whole PDF that I've uploaded with lots of student examples. So if you want to have a look, and if you like this kind of stuff and you think my teacher should do this, right, all the assignments are in there. So they can go ahead and just grab those if they want to look at them and maybe modify them for your class topic, right? So maybe show them the resource if you think this would be fun to do in class. So I started Zygote Quarterly, so zqjournal.org if you're interested to see it, in 2012 with a couple of colleagues, one from Berkeley. He's running the Green Chemistry Society there, or department in Berkeley, and a colleague from Toronto in Canada, who's also very active, but more on the sort of engineering side of bio-inspired design. So I wanted to provide students with a little bit more material than what could be found, say, in the media. You know, Ask Nature was there, which is a great resource, and I still use that every year with my students, right? And that's where they get the best information for the projects. Zygote Quarterly was a little bit more about telling the story behind some of these innovations. And, you know, we are now at issue 28, so we've kept going with it. And you can see here, right, we show science, art, engineering, and design. We have 28 issues. We have a book published as well as The Science of Seeing. So that's our sort of short stories about observations in the desert by a person who also works at ASU, Heidi Fisher. And we have 8 issues in Spanish. So if you're able to speak Spanish, unfortunately, I never learned that, but if you're able to, you can dive into these issues. And we did that in collaboration with a Mexican university. We got some nominations for Science and Nature magazine. And just really quickly, I know time goes super fast at these events. So in 2016, I went and gave a presentation in Cleveland at NASA Glenn. And we then decided to do a project that combined space with bio-inspired design. So 900 students kind of looked at challenges for space, right? So materials for extreme environments, persistence of life in extreme environments, guidance and navigation, and in space propulsion, things like that. So there was this kind of flow to the project. Students, again, did lots of drawings, right? So here's a boxfish, and they came up with a design for a turbulence detector. And this was a student who was looking at slime mold. If you have never looked up slime mold, it's a super interesting organism. Anyway, so you see her drawing here, and then she had an idea for an algorithm, which actually exists already, but an algorithm for wayfinding that she could use. So the students that had the best projects, right, we were able to visit They were able to come with me in 2017 and visit some of the research labs at NASA Vine. And we did a special issue, if you want to read about all the people that are working in this realm. And I think that is probably my time. So I want to leave it with that.
Awesome. Thank you very much. I appreciate it. So speaking of your last slide here, one student asked, did the tardigrade survive?
Well, that's a good question. um, we know that they are able to go into this dormant state, and that they can stay dormant for 30 years and then exposed to water. They could potentially get up and walk away, but of course, they're dealing with huge amounts of radiation, and we don't know how well they're going to be dealing with that for a long period. So if I had to guess, maybe for a couple minutes, but beyond that, but if they manage to bounce under a rock, maybe in 2024, when we're supposed to be back there, we can find a little colony with a tiny little flag under a rock with tardigrades. I don't know. I'm goofing off, but probably not. Let's put it that way.
Okay. Another question, and one I was pondering myself is from a student, do you need to be able to draw to be in this field?
No, but you can always learn to draw, right? So, and yeah, I think, Alex, I don't know if Alex, I think, is still on the call. Drawing is a great skill, and it's great to sit down with something, and in my view, you don't really see something until you try to draw it, right? Because you have to look so closely at something. But I think people misunderstand drawing with being good at it. You don't have to be good at it, right? You just have to look, and no matter what comes out, you're going to see more than if you don't try that. So.
Okay. Well, thank you very much. We're out of time,
I know.
Marjan, and
Yeah.
appreciate you being here today, and learned a lot.